Hello friends, in this session we are going to discuss about the design of sprinkler irrigation system. This slide will show the complete summary of design of sprinkler irrigation system, which parameter we need to take into consideration. So one is your inventory of resources and conditions. Means we have complete idea about your field and selection of your sprinkler system and layout. Next, soil water parameters, discharge of your sprinkler and spacing between your laterals, spacing between your sprinkler also we need to take into consideration. Next, capacity of your individual sprinkler and pumping system and pattern efficiency of your system or sprinklers and hydraulic design of your sprinkler, like your nozzle diameter, pressure, area, spread area, breakup jet, water application from your sprinkler irrigation system we also take into consideration. Next, power requirement of your pump, total power required to the pump the water. So what is the power required at the pump? We also need to take into consideration. And your design of your lateral, submain and main, like your water distribution system against your friction losses. So these all parameters we need to take into consideration while designing your sprinkler irrigation system. So let us discuss one by one. First one is the inventory of resources and condition. So in this system, the sub parameters are your map of area. So complete map. Suppose this is your area, we need complete map of your field. So that is your contour maps, location of your water sources, location of your pump, location of your main, submain, all these things, water supplies, source, availability and dependability. Means that is which type of water source you are using, the surface, groundwater or, and availability means how frequently and maximum water requirement of your crop. Okay, whether you are applying the water on annually or seasonally on conditions, that is your to meet the maximum demand of crop, like the climate conditions such as your temperature, wind, relative humidity, radiation of intention and peak rate of consumptive means simply water requirement of your crop. So that peak rate of consumptive use means the simply water requirement of your crop. So this parameter, these factors also we need to take into consideration. Next, normally a peak demand in the range of the 2 to 10 mm depth of water per day is equivalent to the continuous flow of 0.23 to 1.16 liter per second per hectare. Next, depth of the irrigation. So this depth of irrigation is calculated based on your soil and moisture condition. Okay, this is calculated based on your field capacity, wilting point. Okay, so if different date you can get the total depth of the irrigation water or available soil moisture in the soil. Okay, next, irrigation interval. So this is the irrigation interval, mean how frequently you are irrigating the field. Okay, fortnightly or weekly or 20 days or 30 days or like based on your consumptive use means total requirement or peak consumptive use of your crop. Next, water application rate. So this water application rate will majorly depends on your infiltration capacity of soil. So there are different types of soil have different infiltration capacities such as your sandy soil, clay soil, loam soil. Suppose sandy soil a high infiltration rate. So here we need to apply the water less depth but frequently as compared to clay. Clay has a low infiltration. We will apply the water very less but for longer duration. Means irrigation interval may be long. So like that. Next, sprinkler spacing. To achieve uniform application of water for the crop, to achieve the uniformity of the sprinkler, it is necessary to overlap the each sprinkler. If you take the two sprinkler, one and second one, so it will cover the area or radius diameter this much, and another sprinkler is that is poor condition. So in this condition we should overlap the system. Okay, that is the overlapping condition of your sprinkler. In this condition you get the maximum uniformity, but in the high windy condition it will increase more than the required. So that will we need to take into consideration of the overlapping of sprinkler. Table will tell us that maximum spacing of sprinkler under the wind condition. This is your sprinkler system. This is covering area cover under the wind condition. This image in the circular shape, so it will come like this, complete circular path. Okay, this is center of your sprinkler system. So this is your radius and this will cover entire diameter. So this diameter, how much overlapping or how much diameter is covers based on the wind condition, like in kilometer per hour. Suppose there is no wind or minimum wind is there, in this condition the maximum area of diameter is 65% of your diameter water spread area of your sprinkler. But whereas the wind speed increases, the spreading area or diameter of the spreading area, this area always reduces. Suppose this is cover the 65% when the no in condition more than the 13 km per hour. In this condition, the diameter is only this 30% of your diameter of water spread area of the sprinkler. This means the higher wind condition lead the lesser diameter, mean lesser distribution of water. So there is chances of overlapping, uneven distribution of water condition. So this is the most important parameter we need to take into consideration. Next one is your type of sprinkler and layout. So one is the type of sprinkler. So there are two types of sprinkler. One is a rotating and perforated type. So in this rotating also we had discussed about the perforated, semi-perforated, permanent, semi-permanent and pivot. But whereas the perforated system operated under low pressure, that is a 0.5 to 2 kg per centimeter square. Next one is sprinkler selection and spacing. So this spacing means the selection of sprinkler will depend on your coverage. As I told you, diameter of the coverage, that is how much area this sprinkler, how much area is covering. Okay, total how much area is covering, that is called diameter, and pressure at the sprinkler nozzle. Okay, and discharge from this nozzle, how much Q or what is coming out from this nozzle, and application or type of your soil, which type, whether it is sandy, clay or loam, and slope of this field, whether this field is completely uniform or undulating soil, or all condition maybe depends. So the complete required discharge of individual sprinkler is a function of your spacing of your lateral and spacing of your sprinklers. Okay, on your lateral, like if you see this diagram, so this is the complete layout of your sprinkler irrigation system. Okay, so here the main, the sub main, and these are laterals. Okay, if you focus this, so this is the lateral sprinkler one or lateral, and this another lateral. So this is sprinkler, and on same lateral second sprinkler, and second lateral sprinkler one, and this is the sprinkler. So this is the called spacing between your lateral and spacing between your sprinkler to sprinkler. So this is 10 by 10. So in this condition, we can take the discharge of this individual sprinkler like this, the spacing between your sub main into spacing between a lateral, and application rate, that is your how much amount of water is coming, okay, per minute, that is in centimeter per hour or meter per hour, meter per second, like that. So that is the formula we'll use. In SI unit, we can simply write that the spacing between your main or spacing between your sub main into spacing between your lateral and application rate. So this is the in meters, this is also in meters, and application rate in meter per second. So what is the formula? Like discharge is meter cube per second. So this is a complete simple formula in SI units. But whereas this 1 by 360 is the conversion factor, where the discharge of the individual sprinkler in always taken to liter per second, and application rate, I is the application rate, that is your centimeter per hour. If you use this centimeter per hour and liter per second, we will get the 1 by 360, this conversion factor. Please don't confuse. And in this complete system, suppose I need to, how many number of sprinklers are there? Suppose in the lateral 1, 2, 3, 4 sprinklers are there and one lateral. Like how many laterals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here in the one side total, one side is 40, another side is 40, total 80. So to calculate this number of lateral sprinklers on your complete area, we can estimate this total area by spacing between a main line or sub main and spacing between laterals. If you use this formula, you can simply estimate the total number of sprinkler required per your area. Next, optimum discharge of your area based on your minimum operating hours. Suppose you are operating the system for a 1 hour or 2 hours or for a 6 hours. If you know the time and you know the volume of water coming from your system, so you can get the discharge. Okay, that is your total optimum discharge rate. Based on the water demand, based on your crop water demand, we also estimate the volume. This volume you can estimate Kc factor, the crop coefficient, and soil stress and reference evapotranspiration of your crop. If you know this parameter, we can multiply with the area and application efficiency. This formula, we can get the total volume of water, and if you know the time, you can estimate the simple discharge, optimum discharge from your area. Next one is the height of sprinkler riser. So this is the simple riser, okay, above the height, above the crop, and this is complete nozzle. So in this condition, the sprinkler is located above the height of the crop, to be irrigated. So the height is also depends on your crop height. So to avoid the excessive turbulence, neither this riser height is not too long or very small. So in this condition, we will decide the minimum height, that is 30 centimeter height will required when the pipe diameter is only 2.5 centimeter. Means this diameter, the diameter of this riser is 2.5 centimeter. We can height of this sprinkler is only 30 centimeter. When the diameter is, that is 1.8 to 2 centimeter, in this condition the height may be little lower, that is up to only 15 centimeter. So next one is a pattern efficiency or distribution efficiency. Let us understand the procedure before going to the definition of this system. Now select a field as shown in this picture. Select any field where you want to evaluate the distribution efficiency of your sprinkler irrigation system. The cup should be placed in the square pattern at 7 to 10 feet apart. Like here in this picture, the sprinklers are, these are the laterals, 1 2 3 sprinkler in the one lateral, and second line 1 2 3 sprinklers are on another line. So these are the dotted or collectors, we call cups. So these cups are should be multiple of 4, like 16 cups you should use, 24 cups, 40 cups, or 54, like that. So now the collecting time before the in morning time, or where the minimum wind condition is there in entire day. So let us see here the video. Now such type of cups are arranged in a field in grid pattern, okay, required location as shown in this picture. Now these are the 16 to 24 or 40, like as I told you. When the sprinkler it comes operate, this water will collect in this cup and you should measure, okay, like this. And now the distribution uniformity is calculated by using the average of smallest 1/4 of volume by average volume of all cups into 100. So that means if I take in the 24 cups, one cup, what is the volume of water collected in the one cup? That is 47 ml, assume, and average of this 24 cups, that is 55 ml. So now the what is the minimum value? That is 47 of the 1/4 volume, that 47 by average of all 24 cups, that is 55 into 100. Now I will get the uniform coefficient or distribution pattern is 85.45%. So this is the simple how in this way we will estimate the pattern efficiency or distribution efficiency. That is the point here I given, that is calculated with the total depth of water collected at each can be placed in the grid pattern. The minimum depth is calculated considering the average of the lowest 1/4 of the depth collected in a one can. So the pattern efficiency is useful for calculating the average depth to be applied for a certain minimum depth. So why? Because this pattern efficiency tell us the how much depth of the water is applied for particular region. Also it will give the uniform distribution, whether it is water is coming in circle pattern or distributing in circle pattern or not. So with this we can get the wetted diameter from the each sprinkler. So next one is application efficiency. So application is minimum rate caught by applied rate into 100. This will tell us the application efficiency of the sprinkler. So next one is the uniformity coefficient. The uniformity coefficient is also called as the Christian's uniform coefficient. It defined as that it is a measurable index of a degree of uniformity obtained for any size of the sprinkler operating under the given condition. It will tell us the degree of uniformity, how our system is uniformly distributing the water in a circular pattern. So this uniformity coefficient is affected by the pressure of your nozzle, sprinkler spacing and wind condition. Suppose the high wind condition is there, the wetting diameter will affect, but where is the no wind condition, the good uniformity will or complete circular pattern will give the maximum result. As I told you, in no condition the maximum diameter is 65%, and when the wind condition more than 30 km per hour, in this condition the diameter is only 30%. So this diameter will reduce, uneven distribution possible. So here in this less wind condition also the good distribution uniform degree will possible. So in this condition the uniform coefficient is calculated by this formula, that is 100 into 1 minus sum of x by m into n. So here the C is the uniform coefficient in percentage, m is the average value of all observation. So that is the average value of all cups, as I told you. So in this case I taken 24 cups, and the total volume of water collected in this cups, average of this is 55 ml. This will give you your m value, and n is the number of observation. How many cups you have to get? That is of course 24, and x is the numerical deviation if individual observation from average application rate. So that is the total deviation. Okay, sum of this maximum deviation, where n is the numerical deviation of individual observation, okay, from the average application rate. So deviation from this average application m to x, so that will give you a total sum of x. So now the uniform coefficient range is, as I told you, this is a measurable index. Okay, this index means number. So this is a range from the 0 to 100. So when the 100 is, the CU is 100, shows the absolute uniformity application. It is obtained by overlapping of the sprinkler. So here the maximum uniformity will possible when this system should be overlap. In that condition, it will be 100%. Where the CU is more than the 85%, it should show the satisfactory uniformity application. So in this condition, we can say that our system will get good condition. The uniform coefficient value or efficiency reduced means there is less uniformity of water application in the field. So means the value is going to reduce. CU is 80, CU is the 70, CU is the 60. That means there is a application of water from the sprinkler or from the system is reducing. So there is no distribution of the water for the crop. So what is the use of this CU is, it helps us to the selecting the combination of the spacing, discharge of sprinkler, nozzle size and operating pressure, and also obtain the high value of irrigation efficiency at specific operation condition. So this is the major help of the uses of your uniform coefficient. Next one is the capacity of sprinkler irrigation system. The capacity of the sprinkler irrigation system depends upon total area to be irrigated, net depth and gross depth of the water to be applied, and water applied at each irrigation time, and operating time of your system and application efficiency. So based on this parameter, you can write this formula, that is Q is equals to 2780 into area into depth of the water applied by irrigation interval, time, operating time and application efficiency. Or you can write these are in Q in liter per second, I in days, and application efficiency in fraction or percentage, area to be irrigated in hectares, gross or net depth is in meters, and operating hours may be hectare per day. Suppose if you use, this is the conversion factor. Otherwise you can also use in SI units, that is area into depth of water applied and irrigation interval into operating time into application efficiency. Okay, if you get all the values in meter square, depth in also in meters, so this irrigation interval in days, time operating in days per hour, and application efficiency you can use in percentage or fraction. So this is gives the capacity of the sprinkler system. So total volume of water, total system of your capacity or pumps, how much water is applying from the pump, it will calculate from the capacity of the sprinkler irrigation system. Next one, most important thing, please remember this is the most important. From this we can expect the number of questions, that is the hydraulic design of sprinkler. So hydraulic design means the sprinkler, if you see the sprinkler, it consists of the nozzle, and this nozzle plays a major role. It will break the water in a small drop and it will create the thrust of the water. Okay, here those parameters are: one, discharge of sprinkler nozzle, water spread of the sprinkler, break-up jet and application rate. So first one, let us see the discharge of the sprinkler nozzle. So this formula is given by the Torricelli. Discharge like RFI, it's small hole. So that's why we'll use the RFI's formula, that Q is equal to CD A under root 2GH. The Q is the discharge from your sprinkler, C is the coefficient discharge. So this coefficient discharge, this sprinkler is high, and A is the area of nozzle from this, or area of the orifice, diameter, and G is the acceleration due to gravity, H is the pressure head from the nozzle. From this formula we can calculate the coefficient of discharge is inversely proportional to your diameter. Okay, and discharge also inversely proportional to your diameter from this formula. Next one is the water spread area of a sprinkler. Means suppose this is the sprinkler. Okay, so how much area will spread? How much area will spread like this? Okay, so it will spread after the ground surface. So this is the complete area or diameter. If you know the diameter, you can calculate by using this formula area. So this will give the how much area it will cover in a circular pattern. So that is called your water spread area. For rotating head sprinkler, the area covered by the each sprinkler is given by the R equals to 1.35 root of H into D. Okay, this is the R is the radius of the wetted area covered by the sprinkler. H is the pressure head created by your sprinkler at the nozzle, and D is the diameter of your nozzle. Okay, so the maximum area coverage will obtain when the sprinkler will operate at the angle 30 to 32 degrees above the horizontal, and the rotating sprinkler are standardized up to the 30 degrees. So this is in this condition the maximum coverage may be possible. Please remember these values. Next one is breakup jet. So breakup jet given by Tanda. The breakup jet is tell us that the water is required to attain a uniformity of the coverage and the minimum size of the big drops, which reduce the soil erosion while irrigating the field. Suppose the water is coming from the nozzle. Okay, so in the very fine droplet, suppose the water droplets are bigger sizes, that will hit the soil and there is a chance of erosion, and there is a chances of the damage of the crops or in flowering stage especially. So in this condition, the drops which are falling coming from the sprinkler should be minimum or fine. So in this is tell us that the breakup jet. So that is called your PD equal H by 10 into Q power of 0.4. This is the formula. So where the breakup jet is more than the 2, this is tell us the good condition. When breakup jet equal to 4, it is tell the best, and more than the 4, this is the not good condition. It tell us the waste. So there is a pressure is waste, high pressure is there, and the more water is hitting the soil under the high pressure. In this condition, there is a damage to the soil crop like that. So here the PD is breakup jet and H is pressure head nozzle, Q is a discharge of individual sprinkler. The breakup jet is usually increased by the having the slot in the nozzle. So that is your nothing but diameter of your nozzle. Okay, by a pin impinging on the jet, the slow rotating sprinkler which make the 0.67 to 1 rpm. The revolution, that is a 0.67 to 1 rpm for a small sprinkler and 0.25 to 0.5 rpm for large sprinkler, providing good coverage. Next one is the rate of application. The rate of application is also called as the precipitation intensity, and the average rate of application for a sprinkler system is can be computed by the, so as if you know the discharge formula, that is your spacing between your main or sub main and spacing between your lateral into application rate, okay, by 360. Here the application rate I is the simple discharge by remaining parameters, the Q into 360 by spacing between lateral, spacing between main, or also sometimes the spacing between the sub main. So here we can write this gives the total area, so that area Q, that 360 into Q by area. Also can estimate the simply in a SI unit, that is the application rate equal to discharge by spacing between your lateral, spacing between main or sub main. So this will give simple formula. This is the spacing between your sprinkler to sprinkler 9 meters and spacing between your lateral to lateral, this is the 9 meters. So you can say the 9 by 9 grid. Now other points should be considered, that to improve the distribution under the windy condition, the sprinkler should be operated or moved only by 1/2 of the normal spacing, and irrigation at night time only or where the minimum wind condition is there. The pressure at the sprinkler nozzle can be observed using the pressure gauge with the pitot tube attachment. Okay, to study the water distribution pattern of the sprinkler, the 3 sprinkler is selected. One can set around the sprinkler in grid pattern as I told you. Okay, the can be placed at 1.5 meter apart. Each can should be placed at 1.5 meter apart when there are sprinkler less than the 10 meters, and are placed when the 3 meters distance when the sprinklers are more than the 10 meters. Next one is the design of sprinkler laterals. So these are most important parameters. The sprinkler laterals has equally spaced sprinklers along its length, generally 5 meter, 6 meter or 12 meter. Diameter of the sprinkler is 10 to 20 mm with operating pressure of the 2.5 kg per centimeter square. So the flow goes along the lateral, its volume will decrease obviously. Okay, and discharge of the each sprinkler. So the laterals are made with the LDPE, that is called low density polyethylene, and LLDPE, that is a linear low density polyethylene materials. So the friction from these laterals is calculated by using the Scobie formula. So this is the formula for the sprinkler calculation. So we are not going to details to calculate this derivation. Okay. When the friction loss is calculated, the elevation is added if the lateral goes upside. Means our field is undulating like this. So when this condition, the friction losses is calculated, the elevation should be added. Here height is increasing in this condition. So here elevation should be added. Okay, this much. How much height is there? The head should be added. And when they drop, so in this condition, the elevation should be drop. So that is the elevation should be subtracted when the lateral goes downside. It is recommended that the total pressure variation in the lateral it should not be more than the 20% of your operating pressure. Okay, that means the starting of the sprinkler in the entire lateral, and this is the end of this your lateral. In this condition, the total pressure variation should not more than the 20%. So from the starting to end, so there is in this difference between these two sprinkler, there should not be more than the 20% of your higher operating pressure. So the correction factor should be accounting for the decreasing flow along sprinkler, not called by your Christian friction factor. So this is called area of correction factor. By using this correction factor, we can manage your flow rate in the lateral. So next one is your design of your main and submain. The function of your main and submain is carry the water from your source to field or to the lateral under the maximum pressure condition. This mainline diameter is selected based on your rate of flow, friction losses. Suppose the pipe is larger, the friction losses are very less. If the pipe is small, so in this pipe the friction losses are higher. And if you are going to the large pipe, it leads the higher cost. So in this condition, based on the friction, based on the cost, we should select the pump. This main pipe is made with the PVC and HDPE. The friction loss in main pipe for a small system and 12 meter for a large system is allowable. The pipe having the 65 mm diameter, and in this condition the pressure is up to 4 to 10 kg per centimeter square will maintain for the mainline system. And sometimes the submain system also made with the LDPE having the diameter 32 to 75 mm with the pressure condition 6 kg per centimeter square.